In this section, we're going to talk about solving triangles. And in Math 2, we did a lot of solving triangles, but all the ones in Math 2 were all right triangles. And so we're going to compare right triangles and non-right triangles and the different techniques we need to solve each of them. So with right triangles, like this example here on the left, I know it's right because I have that 90-degree angle right there. And so since it has a 90-degree angle, I can use SOHCAHTOA. So I'd be looking at that 30-degree angle, and then I'm given the opposite, and I want to know the hypotenuse. So my opposite and hypotenuse are involved. So something with O and H, which is the S from SOHCAHTOA, so I'm going to be using sine. So using sine, here we go. Okay, I'm going to say the sine of 30 is equal to 5 over x. And my next step from there would be to multiply by x on both sides. And that gets me to that second step right here. And then my final step is to divide by sine of 30, which gets me to here. And for our absolutely final step, you could just go ahead and use a calculator. So it's great if you kind of memorize that sine of 30 is 1/2, and you can see that 5 divided by 1/2 is 10. But if not, using a calculator is fine for right now to get that final answer of 10. Okay, now looking at this question on the right, this triangle on the right, well, there is not a right triangle. There's no 90-degree angles. So when there is no 90-degree angles, then SOHCAHTOA will not work. SOHCAHTOA only works with right triangles. So I know I keep saying it, but it is a really big idea and a very common mistake that people try to use SOHCAHTOA when it's a non-right triangle, and that's not going to work. It's not going to get us the correct answer. Okay, so we know that if it's not a right triangle, like it isn't in this case, there's no right angles, then we cannot use SOHCAHTOA. So if we can't use SOHCAHTOA, what can we use? We need something else. We need another piece of information. And that piece of information is law of sines. So if you have a triangle that doesn't have a right angle, the first thing to try is law of sines. That's what we're going to learn right now. Before we do, I want to talk about this symbol up here, right here, that's kind of like the O with a line through it. We say that as theta. Theta is basically a name for an unknown angle. So it's kind of like X, but we use it for angles. And that's really to differentiate, so that we can notice when we're talking about an angle rather than we're talking about a side. Okay? So the law of sines is, here it comes, the sine of an angle over its opposite side is equal to the sine of another angle over its opposite side. So what I said in this case is I said sine, taking the sine value, which is just on your calculator, you can take the sine of anything. So taking the sine value of theta 1, so of angle 1, divided by the side opposite. So I'm going to go side 1. So sine of angle 1 divided by side 1. Sine of angle 1 divided by side 1 is equal to sine of another angle, so we'll call it angle 2. So sine of angle 2, or theta 2, over the side opposite of that angle. So over what's opposite that side? Side 2. Okay. So just kind of another way to think about the same thing. I just kind of wrote it out a little bit more in words here. Okay, that says the same thing. So sine of an angle 1, any angle, divided by the side opposite of that angle 1 is equal to sine of angle 2 divided by this side opposite that angle 2. Okay, and these are both saying the same thing. I just kind of wrote them differently, whatever way makes a little bit more sense to you. But what we're talking about here is the law of sines. And if it's still a little fuzzy for you, don't worry. We'll put it into play with some examples, and that should make some more sense. Okay, here's our first example using law of sines. So perhaps the first thing I'm going to check is, let's go ahead and take a look at this. Is this a 90-degree angle? Is there a 90-degree angle anywhere? No, so it's not a right triangle. Means we can't use SOHCAHTOA. I kind of left that reminder up there. It's not going to work. We need some kind of new system. And that new system is law of sines. Law of sines. So at least I'm going to try to use law of sines. Here's my law of sines skeleton. So I usually like to kind of draw out what I call a skeleton the first time I'm using some kind of equation. And I'm going to go ahead and highlight all of the blanks that we're going to fill in. So it's going to be sine of some angle over the side opposite that angle, and that's equal to the sine of a different angle, over the side opposite that angle. Okay, so eventually I need to fill in all of those blanks. And you might have caught that I said we want to try to use law of sines. And here's the thing that we need in order to be able to use law of sines. We need to have both an angle and an opposite side where we know both of those values. So with law of sines, I always want to start with a known angle and a known opposite side. So for example, if I looked at this 40 degrees, well, what's the opposite side? X. X means I don't know what it is. So I don't want to start with that. Right now, just looking at this information, I'm not sure if I can use law of sines yet. But then when I look at the 30 degrees and its opposite side, which is 5, well, I know 30 degrees, that's a known angle, and I know 5. So I know both of those things. So that is really good news for me because that means I can use law of sines. So first thing, I'm going to look for an angle and an opposite side where I know both of the values. So I know sine of 30 over 5, and I could say 30 degrees, okay? And that's going to be equal to, what's the other angle that I know? Well, I also know, the sine of 40 degrees over x. I don't know x, but that's okay. And so from here, I'm going to go ahead and do the algebra to solve. Okay, I got rid of the video to make a little bit more room for all of the work. So here I have a fraction is equal to a fraction, so I can go ahead and just cross multiply. So I'm going to take the denominator, the 5, and then times the sine of 40. So 5 times the sine of 40, and that's going to be equal to the first numerator times the second denominator. So I might say sine of 30 times x, or maybe x times the sine of 30. And from here, I'm going to go ahead and grab my calculator. So the sine of 40, I definitely don't know what that is off the top of my head. So I'm going to grab my calculator and plug that in. So my calculator tells me that the sine of 40 is about 0.64 if I just round to 2 decimal places. All right, and then the sine of 30, that one's nice. That's 1/2. Maybe we could just be consistent and stay with decimals. So I'm going to say the sine of 30 was 1/2 or 0.5. So I'm going to go 0.5 times x. All right, let's do one more step. Again, I might go to my calculator and say 5 times 0.64 is 3.21. A good general rule of thumb is to use 2 numbers after the decimal place. Sometimes we will need to go more. We'll kind of talk about that with something else coming up. But a general rule of thumb is to go 2 numbers after the decimal. All right, so I'm just about there. Now I need to solve for x. So I'm going to go ahead and divide by 0.5, divide by 0.5. And again, that's a little bit tricky, so we can go ahead and plug that into my calculator. 3.25 divided by 0.5, and that's going to be 6.5. And then so 6.5 is my solution. And let's just make sure that we know, what that means. So 6.5, well, that's x. So that's the side length. So I erased my x up there because I now do know that side length. That side length is 6.5. And let's go ahead and take a look at this triangle here and just think about what else I could do with this. So right now I do know 2 out of the 3 angles. So the only angle I don't know is this one up here. Well, what do we know about all 3 angles in a triangle? All 3 angles in a triangle add up to 180. So if I went 180 minus 30 minus 40, I would get 110. Okay, so now I have that this guy is 110 right here. And let's just kind of think about how I could set this up. So what if I wanted to find my last side? Maybe I'll call it y since we already used x earlier. So maybe I want to find that last side y. Let's think about if I could set it up. So again, I don't have a right angle. I can't use SOHCAHTOA. So I can, or at least I want to try, to use law of sines. So I'm going to go sine of an angle over its opposite side is equal to sine of an angle over its opposite side. Again, I want to start with the side and opposite side that I know. Now that I've done some more work, I actually have two different options. So I could go sine of 40 over 6.5 since I now do know both of those. Or I could go with sine of 30 over 5 since I also know both of those. I'm going to go ahead and choose the sine of 30 over 5. One good reason that I kind of like to choose that is because the 6.5 I did round, so that's not exact. So it wouldn't get me quite as an exact of an answer as using the 30 degrees and 5. But it wouldn't necessarily be wrong if you use the 40 degrees and the 6.5. You would just be a little bit less than exact. Okay, so now what do I want to find? I want to find the y value here. And what's the angle opposite it? 110. So I'm going to be using this set so that I can solve for y. So I'm going to go the sine of 110 divided by y. Okay, I've got a little bit more room for myself. I'm going to go ahead and cross multiply from here. So perhaps take the first numerator and the second denominator. Again, it doesn't really matter which way you do it first. So maybe I'll go sine of 30 times y is equal to the other cross multiplication, which would be 5 times sine of 110. So maybe 5 times the sine of 110. Okay, and we can go ahead and pretty much jump to our calculator. Hopefully we know that sine of 30, or we may remember that sine of 30 is 1/2. So I might call that 0.5. Again, because over here I know that sine of 110, well, that's not something necessarily easy to remember. So I'm going to go ahead and put it in my calculator. My calculator tells me that it is 0.9396. I'm going to round to 2 decimals and go 0.94. It's going to round up. Okay, so then I'm going to go ahead and multiply that by 5 on the right-hand side. And that's going to be 4.698. Okay, so when I round that, that's going to round to 4.70. So I'm still kind of rounding to 2 decimal places, but the 9 is rounded up, so it rounds to 4.70. Okay, here we go. Left side's just hanging out at that 0.5y. And final step here, I want to get y by itself, so let's divide by 0.5, divide by 0.5. And again, that's a bit tricky to do without a calculator. It's much faster with one, so let's go ahead and use it. And get the right color here. And now I've got y is equal to 9.396. So again, that's going to round to 9.40. And so my y value is going to be 9.40. Let's do another problem similar to this. So when I take a look at this triangle, my first check is, do I have any 90-degree angles? And at least it doesn't appear that I do. So I'm going to go ahead and try to use law of sines. So the law of sines, maybe the skeleton for law of sines, is sine of an angle over its opposite side is equal to sine of a different angle over its opposite side. And the first thing I want to look for is, do I know an angle, and do I know the side opposite that known angle? So maybe, first if I look right here, well, the y value, I don't know, and the opposite angle, it doesn't look like I know. Maybe we could find it. We'll talk about that at the end. But for right now, I don't know either of those, so that's not a good match. How about the 50? Well, the 50 I know, that's good. What about the side opposite? I don't know it. Okay, I don't want to start there. How about the 80? I know it. How about the 10? I know it. There we go. So the 80 and the 10, that's going to be where I'm going to start. And this is really what tells me that I can use law of sines. And I'm not going to get to a dead end or anything, but it's going to work. Is when I know an angle and I know the opposite side. So I'm going to go ahead and start there. All right, and then again, I would not want to choose this unknown angle and this y, because if you don't know both of them, then you're not going to be able to solve. So I definitely want to choose this pair, the 50 and the x, because I know one of them. So I'm going to go the sine of 50 degrees over its unknown opposite side, so x in this case. All right, from here I'm going to go ahead and cross multiply. So I've got x times the sine of 80 is equal to 10 times the sine of 50. And now I'm going to run for my calculator. So the sine of 80 from my calculator says that that is 0.98. And so I'm going to go 0.98 times x. It just looks a bit nicer if you put the variable after the number. Okay, and then on my calculator, the sine of 50 is 0.766, so that's 0.77. And when I multiply by 10, well, that's going to be 7.7. And by the way, make sure that you're plugging these into the calculator along with me, because your calculator does need to be in the right mode. Your calculator has to be in degrees mode, so that's really important. So make sure that you use your calculator, you know how to use it. Make sure you're in degrees mode, you're plugging in the same things and getting out the same things. All right, we're almost done here, so I need to solve for x. I'm going to divide by 0.98, divide by 0.98. We'll run back to the calculator, and we'll see what I get. So let's see, 7.7 divided by 0.98, and I get 7.857 or 7.86. Okay, and so there's my x. All right, and you know, that's great. I found x, but we also have that y hanging out. So let's see if I can find y too. So since I already had an angle and a known side, a known angle and a known side, I can start with that same known angle and known side, because I always want to start there when I'm using law of sines. Now I'm going to set that equivalent to the sine of a different angle over the sine of its opposite side. And again, well, since I've already solved for x, x is known now. I could even replace that with 7.86, that'd be fine. But since we're solving for the triangle, I want to find all the parts. So there's 3 angles and 3 sides. So this side right here is clearly unknown. So I'm going to say, okay, well, my unknown side, the sides always go on the bottom, is y. And its unknown angle is right here. So that's, well, I don't really know what that is. Now let's go ahead and think about our setup. If I have both an unknown angle and an unknown side, well, that's 2 unknown things. We cannot solve one equation if I have 2 unknown things. So this right here is not going to work. But let's think about this unknown angle. Well, I know 1, 2 out of the 3 angles in a triangle. So if you know 2 out of the 3 angles in a triangle, then I can just go 180 minus the other 2. So if I thought of 180 minus 80, well, I'm down to 100. 100 minus 50 is 50. So I guess that angle has to be 50 as well. So now I'm going to use this 50-degree angle and this opposite side to go ahead and plug in for my work here. And now I can go ahead and go about my algebra and solve. So I'm going to cross multiply. So I have y times the sine of 80 degrees, is equal to 10 times the sine of 50. Okay, and I could plug this into my calculator. I'm kind of remembering right here, I just did the 10 times the sine of 50 though, and that was 7.7. So I'm just going to use that same thing, 7.7. Okay, and I actually did the sine of 80 as well. So I'm just going to refer back to that. So the sine of 80 is 0.98. So now I have 0.98 times y. And I can go ahead and divide. And this just so happens to be identical to the other one. So I guess these two sides are going to end up being the same. So I'm going to divide by 0.98, divide by 0.98. And again, this is looking super familiar. So I'm going to get out 7.86. So this happens to be an isosceles triangle where the x and the y turned out to be the same. And again, that's because my base angles of 50 and 50 happen to be the same as well. So here's another example. Let's take a look at this triangle. Again, no right angles. I can't use SOHCAHTOA. Let's use law of sines, or see if we can use law of sines. So sine of an angle over opposite side is equal to sine of an angle over opposite side. I want to start with an angle that I know and the opposite side that I know. So I know 60 degrees, that's a known angle, and I know its opposite side, length 5. All right, and then the other pairing here is going to be that theta, which is the unknown angle. So theta is just something you don't know. Okay, so I don't know the angle, but I do know the opposite side. So there's my setup. I'm ready to cross multiply. So I've got 4 times the sine of 60. And that's going to be equal to 5 times the sine of theta. Okay? All right, so on my calculator, I can run over there and I can go the sine of 60 times 4. And the sine of 60 times 4 is going to be 3.46. All right, and here I have 5 times. You can either do the dot or you can do parentheses, kind of whatever you like better, as long as you know you are multiplying. Okay, 5 times the sine of theta. Okay, now I need to get theta alone. Theta is like my x. Theta is my unknown. So that's what I need to get by itself. So it's kind of my goal to get rid of that 5. So I need to undo the times 5. So the way we do that is to divide by 5. So if I divide by 5, well, that will undo the times 5. Whatever you do on one side, you got to do to the other. So I'm going to use my calculator, divide by 5 over here. And on the left side, I've got 0.69. Okay, 0.69. All right, and that's going to be equal to the sine of theta. Okay, and we're getting close because remember what we want to do is we want to solve for theta. Theta is my unknown. Here's a spot where I see some students make a mistake. They try to divide by sine, which is incorrect. So some students incorrectly think that this says sine times theta, which it doesn't. It's sine of theta. So we can't divide by sine. That would actually be impossible to do. You can try it in your calculator. It won't work. You'll get an error. So we cannot divide by sine. So I need a different way to get rid of the sine. I need the opposite operation of taking the sine. And the opposite operation of taking sine is sine inverse. So if you look on your calculator where the sine button is, right above it in blue or a different color will be the inverse sine. And that is how you undo a value of sine. So I'm going to undo a value of sine by taking the inverse sine. And if I take the inverse sine of the right side, I have to take the inverse sine of the left side. So I'm going to take the inverse sine of the left side as well. Okay, so now I have the inverse sine of sine. Since those are inverse operations, they cancel each other out, and I have just theta. Okay. All right, now on the left side, you might have noticed that I left some room in that parenthesis. And here's where I'm going to follow up with something I mentioned earlier about how our general rule of thumb for decimals is 2 numbers after the decimal place. However, if we are ever going to use an inverse trig function, that means inverse sine or inverse cosine or inverse tangent, if I'm going to take the inverse of sine, cosine, or tangent, we actually want to go further out with our decimals. And the reason is because I am only going to get a value between 0 and 1 that I'm taking the inverse trig function of. And when I think of the difference between, say, 0.5 and 0.6, the difference between 0.5 and 0.6 is actually pretty big. If I'm taking a 50% of something or 60% of something, that can be quite large. And so when the values are only between 0 and 1, the decimals are actually really important. So what I'm going to do is I'm going to come back up here and I'm going to say, well, let's plug this, 4 times sine of 60 divided by 5. And let's go ahead and plug all that back into my calculator. And then what do I get? I get 0.6928. And so I might even come back up here and say, well, most of the time 2 decimals is good enough, but this time I'm going to go ahead and get my exact answer. So I'm going to go 4 times the sine of 60 and plug all of that back into my calculator. When I do that, I get the 0.6928. And now I can go in my calculator, and you have to make sure that you are pressing the inverse sign, which you get to by pressing the second button. And when I go the second inverse sign, I'll get 43.85. 43.85. And again, I can go back to my general rule of thumb for 2 decimals because I'm not taking the inverse trig function of anything. If you want to be safe and you're not really sure when to use more decimals, then you can just always use 4 decimals all the time. Or maybe whenever you're using any trig function, just to be safe, and then you don't have to remember, oh yeah, I really just need it when I'm doing the inverse trig function. But we have our final answer here. Our theta is, and maybe I'll rewrite it so I have room to write that degree symbol. So 43.85 degrees. So right about 44 degrees is what I'm looking at for that theta. Let's do another one where we get to practice finding an unknown angle. So I'm going to go ahead and use my law of sine since there are no 90-degree angles. So sine of an angle over opposite side is equal to sine of an angle over opposite side. I want to start with a known angle and known opposite side. So I'm going to go ahead and start with the sine of 40 degrees over 5. And then my other pair here is sine of alpha. I just used a different Greek letter. And we can use a bunch of different Greek letters for our angles. So we kind of started off using theta. Alpha is another commonly used one. So sine of alpha over 6. From here, I can cross multiply. So I have a 6 times the sine of 40. And that's equal to 5 times the sine of alpha. And from here, I could maybe go to my calculator and start calculating 6 times the sine of 40, but I might be thinking ahead and thinking, okay, well, I'm going to be solving for an unknown angle. I'm trying to find alpha, which is an unknown angle. Whenever I'm trying to find an unknown angle, I'll end up using an inverse trig function, which means I'll need a very accurate decimal. So what I'm going to do is I'm going to go ahead and keep that 6 times the sine of 40 as 6 times the sine of 40 because that's exact. I'm not estimating a decimal yet. So now I'm going to go ahead and divide by 5 directly here so I can keep as accurate of an answer as I can. So I'm going to divide by 5 over here. Okay, now on the right side, I have just the sine of alpha. And on the left side, I have all this stuff. So I have 6 times the sine of 40 divided by 5. And perhaps now you could go ahead and go to your calculator and plug all of this in. So I would do sine of 40 first, then times 6, then divided by 5. And I'm going to use 4 numbers after the decimal. So 0.7713. And again, the reason is because on my next move, when I'm solving for alpha, in order to get rid of sine, I have to take the inverse sine. And when I take the inverse sine of the right side, I have to take the inverse sine of the left side. And when I take the inverse sine, you always want as accurate of an answer as possible. Because just small decimal places can actually make a fairly large difference. So here on the right side, my inverse sine and my sine cancel, I have just alpha. And on the left side, I get 50.47. So 50.47, that's an angle, so I'm going to say degrees. So 50.47 degrees, maybe around 50 or 51 degrees. And just in case you don't believe me, that using 4 numbers after the decimal is important for taking the inverse sign, let's go ahead and take a peek at a comparison here. So let's say, maybe my decimal that I was at was maybe 0.5999. And I was kind of lazy and I didn't even round right, but I said, how about like 0.5? That's the first number. That's good enough, right? And so the inverse sign of 0.5 is 30 degrees. So I would get a solution of 30 degrees. So the angle of my triangle would be 30 degrees. When I plug in the inverse sign of 0.5999, I actually get 36.86 degrees. So that is almost 7 degrees different. And if I'm building a bridge, building a building, then that's going to be a huge deal. If I make something that's 7 degrees off, everything is going to completely fall apart. And so when we are taking the inverse sign or the inverse of any trig function, we do want to make sure that we are accurate to 4 decimals when you are plugging in the thing you're taking the inverse of.